So today we're going to take a look at the probability density function. Before we get into that, I want to first introduce the idea of continuous random variables and what it means. Let's say um let's say we are looking at the age of a person, which I already drew a diagram over here. And if you did do a quick Google search, you'll find out that the oldest person ever lived will be around 123 years old. So the age of a person ranges from 0 to 123, right? Or so that's the age of a person. Or maybe we're looking at the lifetime of a battery. I'm just using random values here, okay? They don't actually mean anything. So lifetime of the battery, let's say the longest time the battery can be used before it run out of power will be like 10 years. So it ranges from 0 to 10. That's the lifetime of the battery. So all these quantities that I'm looking at, age of a person or like lifetime of a battery, each one of these quantities have values that will range over an interval of real number. In this case of the age of a person, it ranges from 0 to 123, a interval of real number. And we call these like continuous random variables. And for each continuous random variables, there exists a probability density function. And so what exactly does that mean? So what exactly is a probability density function? Well, a probability density function is a function that is related to continuous random variables. So let's say the probability density function, it can be used to determine the probability that a continuous random variable lies between two values a and b. Let's say in this example that I have right here, right? If you look above, the age of a person ranges from 0 to 123. So by looking at over here, by integrating from my chosen A, in this case is 40 years old, and my chosen B, in this case is 70 years old, and by integrating the probability density function, it can tell me the probability that if I choose a random arbitrary value of x and that it lies between A and B. Let's say the probability that I choose a random value between this interval and that it lies between A and B is 30%. Then if this age of a person is a continuous random variable and that it has a probability density function of f of x, then if we take integrate from a to b, a is 40. Actually, let me erase that. Which I shouldn't write a and b. I should write 40. Let's say we integrate from 40 to 70 of f of x dx. This should give me like 0.3, and that will be the probability that it lies between my chosen a and b value. So that's what the probability density function tells you. It helps you to determine the probability that continuous random variables lies between any two random values of a and b that you choose, which is can be represented over here that I have already wrote. P, the probability that my x falls between my value of b and a can be the probability of that happening can be obtained by integrating from a to b of our probability density function. But before we get even further, in order for a function to be a probability density function, it must satisfy two conditions or two properties. I already written it down. The first probability being that the probability density function must be bigger than or equal to 0 for all x, okay? Because the probability, it cannot be negative. That'll be a good enough explanation for this one. And the second property is that if we integrate the probability density function from negative infinity to infinity, it should give us 1. The reason being that let's keep looking at our example here, right? So the age of a person ranges from 0 to 123. Let's say, what about from 70 to use screen pen, 70 to 80, right? Let's say this is like 20%, 80 to 90. This is 5%, 90 to 123. That's like, I don't know, 1%. Let's say that if we sum up all the interval from 0 to 123, like if we add up all the probability, it should give us 1, which is why this makes sense, because if you integrate or if you sum up all the probability, it should give you 1. Okay, so let us look at an example right now. Okay, so our example 1 says that our probability density function would be that f of x is equal to x cubed over 5,000 times 10 minus x. for the interval from 0 to 10, and that f of x is equal to 0 for all other values of x. So what does this mean? This means that we have an interval of some kind of continuous random variables, and that it varies from 0 to 10. And then so this continuous random variable we call x has a probability density function, and the probability density function is x cubed over 5,000 times 10 minus x. And then it says that f of x is equal to 0 for all other values of x, meaning that if we choose, let's say 11, 11 is outside of this interval that we have right here. If we plug 11 into our equation, it would give us 0 for all other values of x outside of 0 and 10. So if you choose like -1, 1 million, all these are values that are out of this interval. If we plug it into our f of x, it should give us 0, f of x equal to 0. That's just one of the properties of in this case that is given. So first, the question asks us to show that f of x is a probability density function. And remember what I said, the first property is that f of x must be bigger than 0 for all value of x. And as you can see, our value of x only ranges from 0 to 10. And then all other values outside of this interval should be equal to 0. So it makes sense that f of x is always bigger than or equal to 0. So our first property is satisfied. Our second property is that we need to integrate our probability density function here, and then the result needs to be equal to 1. So let's do that. So let's say we I'm actually going to use blue pen. Let's say we integrate from negative infinity to positive infinity of x cubed 5,000 10 minus x dx. It's not hard to observe that this is fundamentally 0. This is fundamentally the same as if we were to integrate from 0 to 10 of the same function. Because in the question, it already says is that f of x is equal to 0 from all other values of x from negative infinity to positive infinity except from interval 0 to 10. So these two are equivalents because of that, right? So let's I'm just gonna simplify this. I'm not gonna further explain how exactly you integrate this. I'm just gonna use the result, which is x to the power of 4 over 2,000 minus x to the power of 5 over 25,000 of 10 and 0. So if we plug the values in, you'll find out that this is indeed equal to 1. So our first step is complete. Our first step is to verify that the probability, this indeed is a probability density function. And what about our second step? Our second question says that, well, we wanna find out what's the probability that if I choose a random value of x that lies between, let's say, 1 and 4, right? So let's look at our interval here, and our a in this case is actually this is a bit way more to the right. It should be 1 should be somewhere around here. So let's say this is a, which is 1, and then this is this is oh my god, my brain keep messing it up. This is our b, which is 4, right? So the question is asking that if we were to choose a random value of x, what is the probability that it lies between 1 and 4, right? And if you look at our early definition of probability density function, is that we can integrate from a to b and it will give us the probability that lies between it. So in this case, our question asks us to find the probability between 1 and 4, and our a is 1, 4 is b. So we integrate. So actually, let's actually write that down. P from 1. This should be equal to, well, our a is 1, our b is 4, right? And our probability function is x cubed over 5,000 times 10 minus x dx. So we integrate this. Well, this should give us it's the same interval, which is x to the power of 4 over 5,000. Over 2,000 minus x to the power of 5 over 25,000 from 1 to 4. So if you plug in this value, this should give you or minus 1 to the power of 4 over 2,000 minus 1 to the power of 5, 25,000. That's 1. This, if you plug this in the value, the calculator, it would give you 0.0865, and we times that by 100%, which give us 8.658%. So what exactly does this number represent? What this number means is that if we were to choose a random value between 0 and 10, the probability that it lies between 1 and 4 is about 8.658%. So this is what probability density function is all about. It's really useful because it tells us the probability that a random value lies between some kind of interval that you choose, and is really useful. And I hope you learned something this time. And then if you have some interesting idea that you guys would like me to talk about, feel free to put down in the comment. But thanks for watching.